Good enough.
Ladies and gentlemen, thank you so much for coming to our last Lunch and Learn of ClueCon 2021. Today we have Lorenzo, I believe it's Mangani, is that right?
Mangani.
Yes, it is. Yeah, all right. And he's going to be talking to us about Homer today. So thank you so much, and take it away, Lorenzo.
Thank you so much. Since it's a small group, we'll like to keep it interesting to the audience. So that's why I asked to have the camera turn around. So you guys made the effort to be there. So you're gonna have a say into what we're gonna be discussing here. Same for everybody that's online. So it's open mic as far as I'm concerned. So the best way to do a workshop, of course, is to keep it relevant to those attending. So the usual first round is how many are already users. So if any of you already have HOMER installed or have been using it for a day or a year or 10 years, raise your hand or let us know. Write something in the chat so that I can keep it interesting. Okay, great. So I would say good health, something like that. So this means that I'm not gonna obsess too much with like installing and so on. My intention actually, and Alexander's intention, who's there just below me, he's the real inventor of HOMER, the originator of all of this. We thought we would maybe explore a few of the things that normally in these presentations I have at the tail. So let me go back to my slides. So you already know who we are. We just spoke a few minutes ago. So usually, the elements of setting HOMER up are, of course, installing it. So there's a few ways to do that, as you all will already know, but just to keep track. You can either, of course, dedicate a real server to this to the platform. This is going to be the case where either that's your preference, or you're setting up something that's very intensive and or whatever in between. The majority of our users nowadays will either virtualize HOMER, run it in containers on AWS, or something in between. So we offer a few methods of installing, probably none of which is perfect, but they get you to the platform up and running in as little as possible. Then, of course, as soon as everything is installed, that's when things get complicated. You guys can still hear me? See Jason perplexed, so I'm not sure.
Yeah.
So I can still hear you.
Okay,
Jason,
great. Yes, better safe than sorry. So once everything is installed, which typically means spinning up the two key services, which are going to be Haplify server, which is the landing bay for HAP packets that will be coming from FreeSwitch, OpenShips, Kamailio, RTP engine, or one of our sniffers. So there's a bunch of ways, as you know, to map. Our intention is and has always been to give everybody the same flexibility no matter what you use. So whether you have a native platform like FreeSwitch, or you're writing your own server, we have all the bits and pieces. This is probably the most complex part. And then, of course, once you have all of your data in, the setup comes to life, and it's time to configure things like correlation and fine-tuning how the platform works, which is it's something that could take as little as a day or as long as forever, depending on the things that one wants to achieve with the platform. So of course, all of you already know this. All of you already know how it's set up. There's many elements still today. We're skimming the list down, mostly because a bunch of users were not making the choice. So we decided to make it incredibly capable in terms of inputs, and this is absolutely the winning point. So a bunch of platforms can send us either through native HAP or JSON to HOMER, or CLocky now, as you've seen probably in the previous presentation, data. So sending data into our core is as easy as it gets. But then, having so many choices as of where to store it fragmented the ecosystem a little bit. So a bunch of users were just confused. Which one do I need? Why should I use it? Our center of attention has been ClickHouse. ClickHouse has been giving us the performance, the flexibility, and everything else that we wanted. So the new versions most likely will be entirely based on ClickHouse, and they will only give you these extensions as an optional. So if you still want to send something to InfluxDB or publish it to Prometheus or anything else and beyond, you can still do it, but it will be like just an event stream, something completely optional that doesn't necessarily dominate how you use the platform. So again, unless somebody stops me, I would bypass on the installation part. This is like pretty well documented, I think. And if anybody gets stuck, again, our favorite way is to help you directly. So we have a metrics channel where we spend all day, and we have our ticketing system and our mailing list where we try to keep up with everybody. But it's easy to spin it up. But once you have a system up and running, you will not necessarily have traffic inside of it. This is something that we face every day when we set up a new system. We need to validate it, and to validate it, it's kind of tedious to set up a real system, make a real call. So what we do use is HepGen, which is a tool that we made a long time ago, but we still use to this day. It's a little node application that works just like CP. So it basically allows you to create synthetic hep that you can send into the platform. And this is actually what I'm using all day, and both from, let's say, a validation perspective, but also for CI. Let's say I'm configuring HOMER to extract a custom header. And for whatever reason, I have some difficulties, or I want to validate it. Instead of making 100 calls, you can create a fake HepGen scenario that sends an invite with your special header to HOMER. It looks and feels just like any system. So it can emulate being FreeSwitch or anything else. You can send zip, logs, statistics, and we have a few scenarios that do all of that. If you don't use HepGen, I suggest that you at least start it and keep it around, because it's incredibly resourceful when you need to do something. So if you use HepGen, like I just did on my test system, you basically get some traffic that you can use to test HOMER right away before connecting anything else. The foundation is always moving, but generally speaking, you will find the messages tab, which is like the Wireshark view, so raw packets. The call flow, which nowadays is growing. So at the beginning, it was only really a zip call flow. Today, it can show anything that's in the platform. And actually, in a bit, I'm going to switch the screen to a real instance. And then we have optional tabs that might pop up if there's additional data, except export. And those are going to be related to logs and QoS reports. So namely statistics that come from either server or agents connected to the flow. So if an agent is sending statistics, they will pop up. Or if you have connected, like, I don't know, a back-to-back user agent that's generating or receiving RTCP, this will be forwarded. Or if you have one of our special sniffers, you can even get full RTP analytics into the platform. And on a per call basis, they get displayed here. So you can, most people will flip back and forth. The call flow supports aliasing, meaning that you can go into the UI and basically it's HOMER's internal DNS, which is a feature that some users maybe underestimate, and it's used, of course, to make it simpler to read traffic. That's the primary key. So when we have our different levels of support that use the application, it's not always easy to remember what's what by IP, especially in a dynamic environment. So there's an API and there's a special table that keeps tab of this. For most of our customers, we suggest them to provision it in as real time as they can with the reality. So to make it part of their provisioning flow, you're spinning up a new SBC, make it as part of the flow to publish its identity in this table, either through the HOMER API, which is now, by the way, entirely visible in the user interface, and I'll show you at the end. Or manually, which is, of course, only suitable for very small systems. If anybody has a question, by the way, jump in, interrupt me, ask, and Alexander and I can wait to get questions. So when we connect everything, when we want to connect everything, of course, it's about the system. So here, FreeSwitch is going to be king, and luckily, it's one of the simplest to configure for HEP mirroring. So this has been, nice and stable for a number of years, and the syntax is still the same. So we define capture server, which is going to be the receiver. So this is HOMER, basically from the free switch point of view, the protocol that you want to use, UDP or TCP. And this is important, actually. Let's zoom into a second. Most people would just leave it like that. But if your HOMER instance is not in the same network as your free switch instance, and things get busy, using UDP, of course, is just as lossy as anywhere else. So if this is a cloud environment, we always suggest to use TCP, which, of course, it's the same from a capture perspective. But it guarantees that that data that you rely upon for troubleshooting is actually available when you go look for it. So TCP suggested when you need it, UDP when it's local. Let's save some resources. HEP3, mandatory. So it's there because it's important, not really because it's an option. So you should never use anything that's lower than HEP3 if you want time accuracy and compatibility with the latest stack. And then the capture ID, which is it's a integer that's going to identify this sender. So when we want to find out packets that came from a specific point, we can tell after which you just switch it on globally in the stack if you want to, or you can go by individual profiles. And that's as simple as it is, and I think most of you will already know this. Why and when to use this? It's always when your free switch instance is in charge of TLS. So if you're handling encryption here, this is where you want to do it. It's impossible to do it otherwise. So we still get users with the expectation that a passive sniffer could do this job. That is not the case if you configured it right. So it would only be the case if you use RSA certificates from 10 years ago. Outside of a test run, nobody should. So if you're doing things right, this is going to be your best option for safely monitoring your instances without breaking your encryption. So it's really, really critical. The more we go into the future of encryption, the more this is going to be key. How can we attach additional information that HOMER can use? Through X headers. This is the best way to do it because it's transparent. So HOMER will receive whatever the instance is going to be sending it, and it's able to. Go ahead. There's a question.
Sorry about that. We do have one question. If you want to come up here and ask it, you're free to do so.
Please.
Yeah, I just had a question about. I had a question about what you were just talking about with the internal capture on, because we're using TLS, as I'm sure pretty much everyone is. So
Yes.
is that when you have the internal capture on, is there any performance degradation to having that feature on? Is there a reason why we would have it on at certain times and turn it off at other times? Or
good question. Good question. So no, this is because you might have a hybrid environment. So from some points of views, doing things passively, it's easier and cheaper. So you don't have to have your free switch instance do the work unless it has to. So this is for cases where you're passively sniffing everything and you only want to use this feature for what would be invisible. So you might want to switch this on only on the profiles that are actually doing TLS, and then decide to do everything else passively. So it's just a feature of flexibility here that allows you to either have free switch do all of the work, or have it take care of only a certain profile.
So would there be a performance hit to turning that on, or would that be
yeah, of course. As per everything, there is a tiny overhead. I would quantify in very, very small, so a few percentage points. Of course, if you have a lot of packets, the real overhead is on the network stack sending them. And here, Alex, feel free if you want to jump in.
Yeah, exactly. But it's also this is UDP, so it's just, let's say.
Right. That's why I was specifying.
Yeah,
it changes. So what we really want here is to give you all of the options to keep it as cheap and efficient as possible. So sometimes you're going to need to switch everything on and spend as much as you need to spend. Other ways, you can use the hybrid. So have free switch do some of the work. Let's say that you're running it on very, very tiny instances and every, little bit matters. Then you want to, shrink this role to the smallest that you can.
Okay, thank you.
Also, just to continue, you might have a proxy in front of it that's already capturing everything that's sent to free switch. That's also another case where you might want to have some profiles switched off. Duplication is normal, right? In a monitoring environment, especially one with a lot of piping, you would have a proxy, a back-to-back user agent, probably a proxy again, and then the user agents afterwards. And some of those legs will be identical, right? So the traffic between your back-to-back user agent and your proxy, you already have it if you're capturing the proxy. So with this way, you can get granular and have it do what it wants.
Okay, thank you.
Thank you for the question. It was a really good one. And talking about proxies and everything else, of course. Oh, sorry, I was talking about Xheader. So you will fork inside of FreeSwitch and probably fork many times. If you want to keep tab of this correlation within the signaling itself, inserting an Xheader is the best way. So you can define this Xheader at the beginning or have it be the original call ID of the original leg. And this will allow basically the system to follow it as it goes. So as long as this Xheader appears in any of the requests or responses, it doesn't have to be all of them. This is also a common misconception. One is enough. So within one SIP session, if one of the requests or responses contain an Xheader of correlation, it's going to be used, which means that you click one session and Homer is going to find the second, the third, and the fourth forks as it goes. Beyond that, we can also log internal events. You have choices if you want to log this into the new CLocky approach, or if you just want to send them as HEP, depending on exactly where you're going with this or how aggressively you want to use it. So this will allow us to know what FreeSwitch was doing within the flow of a call. So we will see an invite with authentication, and we can have a log to see whatever FreeSwitch decided to do with that. If it was valid, invalid, if it is going to create a channel, answer, destroy, or do any other action. Anything basically that came out of ESL can be correlated and inserted in a call as logs. So that you get a nice picture of what the signaling was doing, what the devices were doing, and also what FreeSwitch was doing right in the middle of that. We already have a question, but just in case, if anybody else also online has something about this, it's pretty simple, but simplicity is what makes this work. So in front of it, we're going to have a proxy, I would say in 99% of the cases. And luckily, our best friends there support the same protocol in the same way or even more advanced. So in OpenSIPs, we have the most advanced HEP implementation, which literally allows you to use OpenSIPs also as a proxy for HEP. So it can, of course, generate HEP mirroring for whatever it's doing internally, but not just for signaling, for events, for context, for asynchronous commands. Basically, everything that you can do in the scripting can be also logged in Homer using HEP, which means the same as we were saying. So if you are not happy just with seeing what ended up on the network, and you also want to have an insight as of what the decision was within the platform, this is the way to do it. And the beauty is that, of course, at the beginning, it's a little bit of a steep curve. But once you make one HEP packet, you'll make millions because it's easier than it sounds. Inside of OpenSIPs, if anybody's using it, we can get into more details. If you have any questions, we're happy to answer them. Otherwise, it's just as documented in the excellent documentation of OpenSIPs. Nothing much to say here, Alexander, unless you want to. I would just slide through this.
No. You can exactly. In OpenSIPs, you can switch between dialogues, transaction, and single messages. Yeah, so you can exactly activate it only once. What on this slide, what you exactly showing right now, and it's very easy. So you should not care about to enable flag in each route block. Just activate it in dialogues or in transactions level, and that's it. OpenSIPs will automatically copy all messages what related to that transaction to Homer.
And the beauty, again, is that you can do it with other things. So if you do, for instance, REST actions or Xlog actions, those will be sent to Homer with automated correlation. So OpenSIPs is automatically going to insert the correlation headers inside of the HEP protocol, so invisible to the naked eye, that will link the result of this REST lookup or an Xlog directly into the flow. So you have to do absolutely nothing. It just shows up exactly in the position where, let's say, happened from a perspective of
and
time.
Theoretically, you can also use the same, let's say, chain to make correlation between WebRTC packets and SIP.
Yeah, it's all the same. In Camaillio, I guess it's pretty much identical, except from a syntax point of view. So it's it's more the old school way with the zip trace module. Again, you define one or multiple receivers for your HEP traffic, and then you use them within your script, either by setting the flag or setting the capture mode, the tracing mode. Did I hear your question? No. Fine. So same thing here, sending H logs, correlation IDs, and whatever else. It works pretty much in an identical way. Yeah.
Also in transactions mode and dialogues mode. Yeah.
Now the RTP relays here also have a role. So if together with your proxy you also have RTP engine and RTP proxy, they are both HEP friendly, so they support it natively. They can be configured to do what you would imagine. So they forward RTCP packets and or any other statistics that they have internally to the platform with the correlation ID. The correlation ID in this context is extremely important because, of course, the two are disconnected. So, an RTP report will not contain any correlation. So you have to go from that to the SDP, from the SDP to the session, from the session to everything else, which we can do passively. But, luckily, those native clients do the job on our behalf. So they know which session they're providing media sockets for, and they just publish it to us. Configuration, super simple. The capture ID, although, is very, very important. So always make sure that those are unique. With last few minutes, is there any special request before maybe I invest this time wrong? Something that somebody existing users would like to see, would like to try, would like to do. We could be talking about correlation. I wanted to show you guys how HEPSub works with API ban, but I really want to leave it up to you the last 10 minutes.
Okay.
Any points in the room? Oh, sorry. Let me look at if anybody in the chat is saying anything.
Hello.
Hey there.
Can you hear me?
Yes.
It was Homer, and I was following along with the free switch integration thing, and in the wiki too, it's mentioned doing the correlation with the XCID, I think it was called when you were talking about it here. Then after that in the wiki, it says to do correlate the thing in Homer so it knows how to track it. Is that still needed to be done?
Well, yes. Good. Oh, fantastic. Thank you for bringing this up. Alex, is this something you want to show?
No, you go ahead because I don't have access on this laptop right now.
All right. So this is going to be a config of Haplify server. So let me actually scroll back and see if I have it right here. Yes, there we go. So this is how it's done. So of course, with the previous step, you have created an XCID inside of your zip signaling, right? So it just means that it's going to be sent back and forth, and then we're going to get a copy of it. In our capture server, which in this case will be Amplify server, you have this array, which is called, oops, sorry, I clicked it. A-leg IDs is an array that can contain multiple headers that you want us to extract data from. This data will be inserted either in the correlation ID or a custom header with the name, depending on a few options how it's configured. So if XCID is in here, you have to do nothing else. So this is automatically extracting this as a correlation identifier. So it will take it for granted that whatever value is in here is going to match something somewhere else on the system, and it will be extracted. So if this is what you meant, this is the only action that you would have to do. Of course, you could have multiple headers, or you could have multiple systems where you bounce the same content with different identities, and this is where you can define it. So this could be XCID, uppercase, lowercase, or changing name as it goes through, I don't know, a certain vendor's trunk, and you can just extract them. Another
part it's here, it's exactly you can make some correlation steps in home application. It's just correlation mappings, it's called. And we have also example on our wiki how to do it. Yeah, so you can exactly make a multiple correlation using multiple fields.
Yeah, then it gets more complex because inside of HOMER itself, so it's multiple layers, right? So you understood that. The first layer, you're injecting the root data that we're gonna use. In the second, we're extracting it somewhere. And then inside of HOMER, we can use it pretty creatively because, again, this identifier can be used to look for other calls that have the same correlation ID. Or we can take it, transform it. Let's say that this is not a XCID, but it's a hash. Or anything else in between. In the other example, you see that we extract something from a sub value. So we can take the value of a header straight or a sub part of that content. So it can get, it can be super simple or super complex. Our job, again, is to make it possible to fetch this information out in an efficient way and then give it back to the user for programming. The programming is done through the mapping part, which I don't know, it's probably the most difficult chapter when using HOMER is, going and hacking out the mapping of the protocols and their correlation works. It's also the most powerful, as usual. With complexity comes power. But that's it.
Let me paste it on here on channel, exactly link to our article, and everybody can read it.
Yeah, it's something that's definitely not super simple to explain in a few minutes, but yeah, all the information is there. Any other questions from the room or the chat? Awesome.
So I just pasted, yeah. Guys, you can see it.
I don't want to monopolize this. If other people have questions, I'll walk away. So we're sending over UDP if it's local network, and if you're sending outside of the network and you're worried about the packets getting there safely, TCP, is it possible to send through TLS, and is it advisable to send through TLS? Or
Yeah.
is it you should just try and send it over VPN or something?
Well, it's absolutely supported, so you can. So both our agents, Amplify and Amplify Server, support it. So you can just give it self-signed or real certificates, and they can do it. What you need to think about is the overhead. So our suggestion is always to do as little as necessary. So if you're typically your monitoring instance will be within the same networking perimeter of whatever you're capturing. That's not always the case, again, when you have a very distributed architecture. So our suggestion is to use the cheapest method between your entity and the capture server that you can afford, and to use many of them at the same time. So don't choose for one method and deploy it everywhere, but try to use all of them for the environment that benefits.
And exactly 5 cents from my side, HEP has been developed exactly to use any streams protocol. So you can use exactly TCP, SCTP, so it's not a problem at all. So we have exactly chunks, length, and yeah, it's entirely.
I would say don't use TLS for that unless you have to, and if it's within your network. This information will end up in a database anyway. So it would be encrypted in transit, but then it would end up in a searchable engine. So you need to think if that really protects anything within your network. And of course, if it does, it's there. It's just one parameter. You can see up here we have a HEP TCP address. There's also HEP TLS address where you can map the port, and off you go. And by the way, since we're looking at this Locky URL, this is how you can use CLocky that we have seen in the previous presentation as the engine for the entire platform. And this is actually where we're going into the future. So the next versions will be a lot simpler and use this mechanism a lot. And I think we are running out of time, but if there are questions, we're happy to stay.
Sorry, go on. Okay. All right. Thank you, everybody. Thanks for coming today. We really, truly appreciate Lorenzo showing us and teaching us all this amazing information here.